colleague from Carnegie Mellon University, and there's another colleague down there who's got a robot. So right there in this row here. And what the robot is doing is it's going to come down through, and if all goes according to our plan, eventually it's going to stop and take pictures. I don't think today it's taking pictures, right, Abhi? So it'll come down through here. Don't get too close to it because we're never sure what it's going to do exactly. And then come around the end and go back down that way, and it'll take stops along the way. But the reason that the robot is taking pictures is that we hope that those pictures will be able to substitute for you going around with calipers and going blind and having arthritic fingers from doing caliper measurements on fruitlets when you're trying to get thinning information. You can also do crop load stuff. I think without further ado, Avi, maybe you can tell them a little bit about what this thing has done in grapes and things like that.
All right, so I'm a research scientist at Carnegie Mellon University, and I typically do research in robots in outdoors. We call our center Field Robotics Center, or FRC for short. It's under the Department of Computer Science and then in robotics. And then these days I'm particularly focusing in agriculture. So down there you see a robot. We call that Bumblebee. It's black and yellow, so Bumblebee. I can name that. We originally designed it for pruning grapevines. So it has a robot arm attached to it. It has cameras. It will scan the canopy, make 3D model of it, and then it will apply any pruning rule that you think of. Spur pruning, chain pruning, whatever it is. And it goes, makes cuts. It drives autonomously. It stops in front of the vine. And with UMass folks over here, what we are doing is measuring the fruitlet size. We're trying to automate that process. So it has several cameras. It takes images of those, and then it sizes that based on the image that we're getting. And then we're just trying to scale it up with robots, essentially. So what's going to happen next is I'm going to ask my colleague over there to drive the robot here. It's going to stop in between all of those red tags that you see there. So those are all of our calibration plots. There are QR tags attached to those clusters. We have a fully automated system where it goes and scans it by itself, but right now for demo, we're just going to do the navigation part. All right, so once this is done, I'll bring the robot close to you guys so you can see it from close. And if you have any questions, then I can answer that too. All right? Great.
Graduate student with Dan Cooley's lab. And from my part, basically what we're doing is we came up with the idea to tag the different clusters and use that. Originally, what we were hoping to do was use a cell phone or something similar. We also have something small like this that maybe you could attach to an iPad. So what we're hoping to do is to kind of cover the whole spectrum. So some of you may be interested in something like that, which is fantastic. And other things may be something as simple as downloading an app from your cell phone, and then you would just go ahead and snap pictures, and you would get the same information.
Is it using LiDAR technology?
So that's an interesting question. We're actually looking at the new iPhone coming out that May. This is using LiDAR right now.
Yes, the LiDAR is in place, but we're not detecting anything with that right now. So the idea with LiDAR is either for navigation or sort of not hitting things in
You could possibly also calculate tree row volumes more accurate.
We can do that too.
And we could do it on a regular basis as the season changes.
Yes. So once the robot has this navigation figured out, it's just a matter of attaching that LiDAR, collecting that, and then this processing either in the robot or later back in the station.
It can do it as it's going, I think.
Yeah.
Right. I mean, you can
see
for $50,000, I could put LiDAR on a sprayer.
Yeah.
So that's the last stop. So let's move a little bit away.
Sure, guys, watch out.
It's gonna turn and enter that row.
Don't get run over.
You've got it programmed to stop at the tag street now?
Yes, it's stopping by itself.
Stopping by itself at the tag street?
Yeah, and then we're just hitting enter to sort of make it move again. So now is the turning part.
This is probably the dangerous part.
Yeah. Put your hands on the e-stop just to be sure. So it emissions in this side of the canopy. It's turning around and it emits the other side of the canopy.